All right, this, by the way, is just a review of what you guys had already learned in 6th grade. It's just that now we're going to start incorporating some 7th grade stuff into it. So you may see some minor differences, but it should be all stuff that you are very familiar with. Write inequalities for each statement below. For statements 1 through 4, the variable is defined for ye. And then we'll have to figure out what variable we want to use for 5 through 15 on these. The Garcia family car seats 7 with seat belts, which is important, otherwise you get a ticket. At most, X is the number of peoples that can sit in the Garcia's car. Now this is 7 at most, so it's really greater than or less than or equal to. Let's look at the symbols. So there's a couple symbols on it, these. These are the ones you should be most familiar with. There's less than, because it kind of looks like an L. Less than. This one's greater than, because, well, it just kind of looks like a G.
So left is the greater and right is less?
What?
So like this one is
Less than or greater than, you know. Yeah, this one kind of looks like a G if you just put a little swoosh in there. It looks like a G like that. But now we're dealing with others, like this one and this one. But now they have these lines underneath them, like these. That it means that we're combining them into 2 different statements. So it's less than. We still have that less than symbol, but now we have half the equal sign as well. So that means that it is also equals. So this other one is greater than or equal as well. Now these 2 at the top means that there's 2 things, but only one of them has to be true, because really only one can be true. If both are false, then it's false. Okay. For example, 5, let's compare 5 with 7. Well, 5 is less than 7. That is true, right? But what about 5 is less than or equal to 7? I remember you guys are supposed to be writing this down, right? That'd be good. All right, so this is true, but let's look at another example up in here. Let's compare 10 with 10. Is 10 greater than 10? No, that's false. But is 10 greater than or equal to 10? Yes, now this is a true statement. Even though 10 is not greater than 10, it is equal. And that's why it's or equal, because it's or equal. So since it is equal, it makes it true. All right, so this stuff we're going to be looking at some word problems as well and figuring out which of the symbols are going to be needed. If by chance a value isn't included, then we use that equal stuff, okay? Number 2, in many states, you must be at least 16 years old to obtain a driver's license. X is the age you must obtain a driver's license. So we're comparing X with 16 on these. Now, is X supposed to be bigger than or smaller than 16 to get a driver's license? Bigger, right? So that means that we definitely want the shall-get to be eating the X. But could it also equal 16? Yeah, because it says at least 16, so that means if you were exactly 16 or equal to 16, that also would be a true statement. If you are 15, then it becomes a false statement. Your age is not greater than or equal to 16. So that's the answer for that one, because all we wanted was this this inequality right here. I put it on the wrong line. Let me change. All right, this next one. It isn't safe to use a light bulb of more than 100 watts in many light fixtures. X is how many watts a light fixture have. So we're comparing X, the amount of watts a light fixture have, with 100 watts. Now, do we want it to be the X, the watts the light fixture has to be bigger than 100 or less than? We want it to be less than.
100 years.
Now, are we saying that it could be equal to 100 watts? Yeah, because it says more than 100 watts, so that means that it could also equal the 100 watts. In many states, that's a school bus can sit at most 48 students. Does that mean that it could sit 48 students?
Yeah.
I have a feeling you're guessing now. Because it's saying at most 48, which means you can't fit 48 people into it. So we know that it's also equal to the 48, the number of people in the bus. But would we make this eat the x or the 48? Yeah, it's got to be eating the 48 because the number of people in the bus at most is 48. So it should be eating the 48. Otherwise, if it was eating the x right here, we would be saying that we're going to be putting more than 48 people into the bus, which is not going to work based on what it told us. At least 250 parents attend back to school night. X is the number of parents that attended back to school night. So it says at least, so the number of parents that actually went is X. And then it tells us it's in comparison to the 250. Now, since it's at least, does that mean that you could have 250 parents attend?
Yes, you just can't have it under it.
That is correct.
Yeah, you can.
You can have equal to 250, but it says at least, right? So does that mean we'd want it to eat the X or the 250?
250.
Yeah, we don't want it to eat the 250. Because it says at least, if we say that if it eats the 250, then we would be saying that there would be less than 250. All right, so the way this reads is, it turns out, because X is greater than or equal to 250, but this is in context. X is the number of parents that attended back to school night. So the number of parents that attended back to school night is greater than or equal to 250. So does that mean that we could have 300 parents attend back to school night?
Yes.
Yes. What about 10,000?
Yes.
Sure. What about 15?
No.
No. Then it's a no, because 15 is not greater than or equal to 250. You must be no more than 15 years old to attend the middle school dance. So we're going to say that X is your age, and we're going to compare it to 15, right?
So it's going to be this.
So you can't be more than 15, right? So is it going to be the 15 or the X?
15.
No, it can't. It's no more than 15.
When we eat the X?
Yeah, so you're right. It does eat the 15 because your age, X, needs to be less than 15. But can it be equal to?
Yes.
Yes.
Yeah, because it's no more than 15. So if you're equal to 15, good to go. Very good. A plane must travel at least 120. Let me start that over again. Let me start that one over again too.
Plane must travel at least 100.
A plane must travel at least 120 miles per hour to stay in the air. So as not to break the sound barrier, a plane must travel under 760 miles per hour. So if we said that X is the speed of the plane, and we compare it to 120 like these. So 120 and X right here like this, okay? So the speed of the plane is X. It says at least 120 miles per hour, right?
So it could give more
So does it need to be more or less?
or less. So it could get a little more.
Yeah, it should be more, right?
Wait.
But could it be equal to as well?
So you can.
Yeah, so we can make it equal to. But in addition to that, we also need to compare, because it says X, we're going to compare it with 760 like these, right? Yeah, very good. So this one is going to eat the 760 because it has to stay under. But can it equal 760?
Yes.
No.
No.
Because up here it says it must be under 760, okay?
Oh, yes.
Now if it said at most, then we would.
So if you stay at 760, then you're breaking the sound.
Yeah, once you hit 760, then you are breaking the sound barrier. So it has to be just under that. Now in addition to this, notice how the X is in the middle of both of these? We could just make this one big inequality. This is called a compound inequality, where we're comparing X with two different things at the same time. And that's it. This would be the actual answer for this one. Children must be at least 48 inches tall to ride the roller coaster. So we're going to compare X, that would be the height,
You can be 48 or
to 48.
You would eat the 48.
Um,
no.
Yes.
it will have a line under it because it's at least 48, which means you can be 48 inches tall. But does your height need to be bigger than or less than the 48? Yeah, it needs to be bigger, so it should eat the X right.
I suck at this. This game is so.
All right, number 8. You must have less than 3 tardies to get a satisfactory citizenship grade. So X is the number of tardies, and we're comparing it with 3.
So you eat the 3.
It eats the 3. Very good. Because we want your tardies to be less than 3, but does it be equal to 3?
But can it equal our tardies?
I have 0 tardies.
Yeah, this one cannot equal the 3
Bro, I have.
because it says it has to be less than 3. So that means that once you get 3 tardies, then you get then you don't have that satisfactory stuff. Yeah, that stuff.
Wait, is that true for?
All right, number 9er. Children younger than age 5 can get in free. So we're comparing the age with 5.
It has to eat eggs.
It has to eat.
5.
Has to eat the 5.
What?
Because your age needs to be less than 5, younger than 5,
But did you say that? Oh yeah.
to get in free.
Eggs more.
To hunt big game, so large animals, in Utah, a hunter must be at least 12 years old. So we're looking at the age, comparing it with 12 years.
No, it is 12. It is 12.
Yeah, so this one's at least. Does that mean you can be 12?
No.
Yes, you can.
Yeah, you can be 12.
So that means you eat the 12.
But is it eating the X or the 12?
Eggs.
Very good. It does eat the X. Very good.
Aha.
What do you guys got on this one then?
Eat the number. Eat the number.
So X and what?
Eat the number with equal sign.
No.
What other number? What number are we comparing this with?
It can be equal.
20.
Yeah.
So it's the number.
So now eat the number with equal sign.
Eat the number with equals. Very good.
Yeah. I know it.
Very good. All right. To work the track at the community gym, you must be at least 16 years old. So we're comparing X with 16.
Please. So you eat
So
the
you eat the X.
the X.
You eat the X.
Yeah,
Equal
you eat
thing.
the
Eats the X
And
And
equal.
you can
with
do it
equals.
equal.
Very good. Very
You
good.
got it separate.
All right, what about this next one? To join the FBI, you must be at least 23, but younger than 37. Yes, this is a double one. This is called a compound inequality. So we're going to compare X with 23 first.
You must at least 23.
Eat the number with a number. I mean, a line under.
All right, so yeah, it is at least, so you have to be at least.
Yeah.
Now, if you have to be at least 23,
The X, 'cause it needs to be
yeah, it needs to eat the
But
X.
for 37, you put.
But now let's compare X with 37,
You
right?
eat the number. You eat the. Wait. No.
Yeah, you eat the number
Yeah.
with a line.
Number with the line?
Yeah, number with the line.
Now this says you have to be younger than 37, right?
Yeah, number.
Does that mean you can be 37?
Oh no.
Yeah, number with the
No,
line.
right? Since we can't be 37,
Oh, so you just put the.
then it would not have the equal part of that, okay? Alright, so there's the first page. To run the class, they must have no less than 12 registered participants.
You eat the 12 with a line.
What?
So we got X and 12. You said it eats the 12?
So you eat the X, the 12 with the line. 12 with the line. Line.
With the line?
Wait, no. Wait. No, yeah, you eat the X because it's no less.
Yeah, that's very good. It does need to eat the X. Because that's the least amount that you can have in participants. So X must be greater than or equal to 12. On the 7-day family vacation, the Jones family traveled 12 miles on the shortest driving day and 500 miles on the longest driving day. So it's a 7-day trip, which really doesn't matter on this, right? So we're just looking at distance traveled, X.
X 12.
We're going to compare it to 12 and 500. So X is the amount they drove on any specific day. They drove 500 miles on the longest day, so we know in comparison to 500, they should have driven less than that or equal to it. But they also traveled 12 miles on the shortest day, so it's got to be more than 12 or equal to 12 as well. So X being the number of miles they drove on any specific day needs to be greater than or equal to 12, but less than or equal to 500. Right situations to go with the following inequalities. Make up the situation and inequality for the last one. We'll do it. Alright, so this is X is less than 7. So what would be an appropriate problem for this one? So we could say, yeah, we have to make one for this.
So, X number.
What do you guys want to?
I know it. You have to have at least 13.
This is 7.
13 years old.
Oh, this is 7.
Yeah, so X is less than 7, right? So let's compare this with elephants. We all like elephants. We like to eat elephants.
You have to have 7 elephants to
So-
go on a safari. Let's just do.
A zoo has less than 7 elephants. Bam, that's it. That's all we got to write. Alright, what about this one?
You have to be less than 13 years old.
Very good, that sounds good. You
Have to be 13 years old or less.
must be 13 or older for what?
To go to party.
To go to the party.
Go to Disneyland.
Disneylandage.
I went to that. Go to the club.
Alright, this one has some negative values though, so we need to figure out how we're going to use a negative on these.
Oh, so you.
Alright, so X, let's just use money because that's pretty easy on this one. So so X is less than that, so you owe your pal
Oh, she's calling me down for lunch attention right now.
$6
So she wants to be sure that I go.
or, well it's less than, so,
Yeah,
or more.
that wall is just bye. Go, guys.
Yeah, so you owe your pal $6 or more,
Yeah.
your pal, whatever.
It's you, pal.
Now, why is it more? Because this one is saying that we have more and more negatives. So you could say at least $6 as well. Either one of those would work. Graphing stuff is stuff you should be used to already. Examine the inequalities below. Discuss the questions below as a class. Just let's review real quick though. So for graphs, if we have less than or greater than, then we have an open circle. Now if it's equal to as well, then we have a closed circle. The closed circle indicates that that value is included as part of the set that would make this true statement stuff. So looking at these graphs, this first one is open, so we know it's going to be less than or greater than, and we're going to have to compare with 2. So here's the thing is, if the graph goes to the right, then it eats the letter. If it goes to the left, then it doesn't eat the letter. So this one is going to the right, so it's going to have to eat the letter. This other one, again, we're comparing X and 2, but this one goes to the left, so it needs to not eat X, but it's closed, so it's equal to as well.
I don't really get this.
So open, it's talking about the open circle on the graph, which is radical. It's open circle. Closed means that we just close in that circle right there like that. Okay. Now, the other thing we need to address is if the line goes to the left or the right. If the inequality eats the letter, the line goes to the right. On the other hand, however, if it does not eat the letter, the line goes to the left. Bam. Now this works the other way, which is how we knew if that was eating the x or not on those two. Because on the top one there, it goes to the right, so we know it has to eat the letter. And the bottom one, it goes to the left, so it should not eat the letter. So let's use this same concept with these other ones. Like 18 there. 18, x is less than or equal to negative 6. Open or close circle? It's closed because it's equal. Right, so on the graph on this one, at negative 6, so negative 5 radical, negative 7. Since it's equal to, we're going to close the circle in. And does it eat the x? No, it does not, so it goes to the left. And this would be the graph. Coming back to these. So again, on a number line, at 13, because that's where it's equal to, we got 12 and 14. So this one, first thing we need to do is figure out, this one's closed, very good, because it's equal to. So we're going to close the circle in.
The x would be going that way.
Is it eating the x?
Yes.
Yeah, so it goes to the right.
So if it eats the x, goes to right.
That's correct.
If it eats the number, it goes to left.
That's correct. Very good.
Also, if it eats the number, then it's a number.
So like this one, right?
It has to go to
At the
left
number
if it's
line.
eating the number.
Yeah, very good. You know it goes to the left because it's not eating the x. So we know for sure that the line goes to the left. The problem is, do we have an open or closed circle at 7?
Open.
It's open because it's not equal to 7. So we'll just put an open circle going to the left. So we'll practice graphing these inequalities. Starting with 19, x is less than 2. So at 2, open or closed circle?
It's open.
It's open, very good. And it's eating the x, so it goes to the
Right.
right, very good.
So the third.
So that's the graph for number 19. But let's look at 20 then.
It's open. It's open.
20 is open at
1.
negative 1. That's a
So
negative
it goes
1.
to left. It goes to left.
And yeah, it's not eating the a, so it goes to the left.
So it's not
This
eating
test
the
is
left.
gonna be easy.
Wait, what do we do there?
All right, what about this next one? 21. Looks like it misprinted that.
That's 21.
So we'll make it less than or equal to. So y is less than or equal to 2. Open or closed?
It's closed.
Closed, going to
It goes to
the
left.
left. Very good.
So
I learned this last year.
Yeah, that's why it's a review, man. All right, this next one, x is greater than or negative 3.
open.
Open at negative 3, going to the
Right.
right. Very good. All right, so 23, we'll just write that one in.
Okay, so
Open or closed at 3.
no, close.
Yeah, very good. Closed at 3,
And it goes to right.
going to the...
Right.
Yeah, that one's eating the p, right? So it goes to the right.
I couldn't tell that before.
24, that's at 0.5. That's a half. So open or closed at a half?
Open.
Open at a half. About right there. Going to the
Left.
left. Very good.
How do you know it's left? Oh, yeah.
All right, 25. Y is greater than negative 1.5. Open or closed?
Open.
It is open. Going to the
Left. Right.
to the right because it's eating the y. 26. Open or closed at 3.5?
Open.
Open. No, close.
Closed. Going to the
Left.
left. Very good.
Close.
Close.
Closed at negative 15/3. That's negative 5.
Close right.
Close right.
Closed going to the right. Very
Open
good.
left.
Close.
Open left.
At 4.25, we need a little more space on that.
Close left.
Closed.
Left.
Going to the left. There it is.
How do you know?
Alright, so there's all of these. Yeah, on these ones, we gotta actually write the inequality for these. So let's start with, what is this, 29?
It's open.
Yeah, it's open, so
It's one.
that's very good. We're gonna compare x with 1.
One eating. No.
Eating
Eating
one.
one.
Eating the 1, very good. Equals 2?
No.
No, because it's open, very good. What about the next one?
Close.
X and negative 3,
Eating the X.
eating the x
Equal.
equals, very nice.
I know, I'm so smart.
What about this one, x and 2?
Close.
And then you're gonna be eating the x,
Eat the
Yeah.
x
and you're gonna be equal.
equals 2 as well, because it's closed, very nice.
This is pretty easy.
What about this next one with x and negative 3?
That's closed, so it's eating -3, and it's equal.
Very good.
Okay, Adrian.
And this next one, x and 3?
So it's open and it's eating the X.
Very nice.
Yeah.
It's not.
Alright, there's our graphs.
The paper is blank.
Activity 1, every hour, 92 people enter an office building and 30 people exit. So if we look at that on a D's, we know that the 92 people are entering the building and then the 30 people are going to exit. So by the end of that hour, we should have 62 people still in the building. Now, if the building started empty, after how many hours will there be more than 350 people in the buildings? So draw a model to illustrate what's happening in this context.
Long enough.
We'll skip that part. In this context, what does more than mean? It means we want more than some number greater than 350. And now write the inequality. So we know that there's 62 people in the building every hour. So if we multiply this by the number of hours, then we will have the number of people in after a certain number of hours. Now we're comparing this though with 350. But particularly we want to know when there will be more than 350 peoples. So we're going to just make this greater than the 350. Or in other words, it should eat the 62x, the number of people remaining in the building. So how do we figure out how many hours this will take? Well, we'll divide both sides by 62, just like we would in a regular equation. And that gives us x is greater than, alright, so 5.65 hours. So we know then that it's got to be x, then it should just be greater than or equal to 6 hours. And this would be the solution to that, 6 hours. Alright, if we double the people entering and exiting, how will it affect the time? It should just cut it in half. Now that would give us something like 2.8-ish. So it'd be still be greater than or equal to 3 hours on that part. A 150-pound person burns 6 calories per minute when walking at a speed of 3.5 miles per hour. While walking, this person eats a snack that has 40 calories. This snack subtracts from the calories burned while walking. How long must the person walk at this speed to burn at least 190 calories? Well, let's look. So if we said up in here that x, we'll say that x is the number of minutes. And we're going to say that for every minute, they're burning 6 calories. Now, while they walk, though, they're going to eat a snack, so we're going to have to take out 40 calories on that stuff. And we want to burn at least 190. So this needs to be greater than 190 calories. That's how many calories we're burning, 6x minus 40, compared to how many we want to burn, 190. So that's the inequality for these. Next, all we got to do is solve these. So we would add 40 to both sides, just like we would on a regular equation. So that gives us 6x is greater than or equal to 230. And then dividing both sides by 6. We get x is greater than or equal to, simplifying that, looks like we should get 115 thirds minutes. So, in other words, to burn at least 190 calories, you would have to walk 115 third minutes or more. So that would be the answer to that one. At least 115 thirds minutes. Explain what will happen if the person walks for a longer period of time, then they will burn more calories. If they walk for a shorter period of time, they will burn less calories. What if the person, write and graph an inequality that describes the solution to this situation. Alright, so we'll make a graph for ourselves. And we only need 3 values on this. This is 114 thirds in minutes, 115 thirds, and then 116 thirds. And at 115 thirds, open or closed cycle. Well, this is equal to, so it can equal that, so it'll be closed. Does it eat the x? Yes, it does, so it goes to the right. There we go. And that would be the graph. Well, what if the person wanted to spend less time exercising but burn the same number of calories? How would they have to do that? Yes?
Not eating snacks.
By not eating a snack or
Walking.
walking faster. Yes, very good.
Or running. Running.
Explore inequality statement. Considering these 2 statements, in your own words, describe the solution set for each and then draw a graph of the solution set. Alright, so let's first graph these actually. So on this one, we're comparing it to, we got 1, 2, and 3. Same with this one. 1, 2, and 3. Now this one here on the left, x is less than or equal to 2. Open or closed at 2? It'll be closed because it's equal to. Does it eat the x? No. So which direction does it go in?
Left.
Left. Very good. What about this one on the right? 2 is less than or equal to x. Open or closed? Closed at 2. Does it eat the x?
Yes.
Yes, it does. So it goes to the right. So describe the solution set for this first one in Poiple. Let's go ahead and put that down right here. So x is 2 or less. And then we also got the red one, which also was equal to the x. So x is 2 or more. There we go. What is the solution set for x minus 1 is greater than 6? In other words, what values of x make this true? Write both an inequality statement and then graph it. Well, for this one, we can see, hopefully, that we would add 1 to both sides of this. So we'd add 1 right here. Add 1, t model. We got x is greater than 7. So that's the inequality. Next, we just need the graph. So 6, 7, and 8. And at 7, since it's not equal, it's open. And it is eating the x, so it goes to the right. What about b? Well, in this one, we'll divide both sides by 2. So that gives us 1x, which is what we want, is less than 3. So that's the inequality on the graph, comparing with 3, 2, 3, and 4. We can see that it'd be open at 3 because it's not equal. And it is not eating the x, so it goes to the left. Then finally, this one, 2 steps on this. We got to add 7 to both sides. So we got 3x is greater than or equal to 20. Then divide both sides by 3. And we get x is greater than or equal to 20 thirds. So that's about 6.6 repeating. So we got 5, 6, and 7. 6.6 repeating. That'd be about right here. And this one is closed because it's equal to, and it is eating the x, so it goes to the right. Describe what you did to find the solution sets. We just use principles of equality, same like we did for solving equations. That's it. So we need to solve and graph these. Let's go ahead and solve them first, and then we'll come back and graph them. All right, so number 1, here we'll need to subtract 8 from both sides. And we got x is less than or equal to 10. On this one, we're going to have to add 2 to get the x by itself. So we get x is greater than or equal to 14 negative. Number 3 right here, we'll have to add 10 and 1/2. So adding 10 and 1/2. That'd be 38.5, but no mixed numbers. Oh, that'd be negative 18.5 instead. So it's a negative 37 halves. 37 halves is less than v, that's okay. Then this next one we'll divide by 4, and we see that y must be greater than negative 2. So those are those ones. Then finally, number 5, we'll divide everywhere by 3. So 7 now is less than or equal to p. So we have all the inequalities. Let's go ahead and graph these now then. Alright, so number 1, we got 10, so 9, 10, and 11, that's all we really need. Open or close the 10? Closed. Going to the left, because it does not eat the x. Number 2, at negative 14, so negative 13, negative 14, negative 15. Open or close at negative 14? Closed. Does it eat the x? Yes, so it goes to the right. The next one, at negative 37 halves, that's negative, yeah. So that's a negative 18, negative 19, negative 17. So it should be open at negative 18.5-ish, and it is eating the v, so it goes to the right. Next one at negative 2, so we'll say this is negative 3, negative 2, negative 1. Doesn't matter where we put those. Open at negative 2, does it eat the y? Yes, it does, so it goes to the right. And then finally, this one, at 7, it's going to be closed, so we'll make it 6, 7, and 8. Closed at 7, going to the right, because it eats the p. So, this would be the graphs for all of these, just a few more left. So let's go ahead and solve these first before we graph them again. So number 6, we'll divide both these by 2. And we got x in comparison with negative. We can do the fraction or the decimal on this, negative 7.5. Right here we're going to have to add 13 to both sides. So that gives us 22 is greater than 4r. Then dividing both sides by 4, looks like r is going to be less than 5.5. Alright, number 9, we're going to have to subtract that 8 out from both sides. And we got 3 is greater than 6n. And dividing both sides by 6, we got n in comparison with 0.5. Next one, we need to add 75 to both sides. So that'd be negative 60 right here. And 5n. And dividing both sides by 5, we get n is less than negative 12. So there's number 10. Then number 11, we need to subtract 18.66 repeating from both sides. 0.66 repeating. And that gives us 2k is less than or equal to negative 8.66 repeating. 18. Well, yeah, it was 10 minus 18 though. And then we'll divide everywhere by 2, so k is less than or equal to negative 4.33 repeating. Alright, and then finally number 12, we need to subtract 16 from both sides. So we got negative 20 is greater than or equal to 4x. We'll divide everywhere by 4, and we got x in comparison to negative 5. So we have all the inequalities, now we just need a graph. Alright, now we're ready to graph these. So, this first one at negative 7.5, it appears that we will have an open circle, and it does not eat the x, so it goes to the left. The next one at 5.5 is going to be open. It does not eat the r, so it goes again to the left. Next one at 3, it'll be open. It does eat the r, so it goes to the right. Next one at 0.5, open. It is not eating the n, so it goes to the left. And then at negative 12, we have open circle. It is not eating the n, so it goes to the left. Then at negative 4.33, which would be about right here, it's going to be closed. It is not eating the k, so it goes to the left. Then finally, at negative 5, we got a closed circle. And it is not eating the x, so it goes to the left again. And there's our graphs for these. All you need to do is use principles of equality, just like you would with equations on these, until there's negatives. Then it will change everything. And we will talk about that next time, though, so we don't have to worry about any coefficients that are negative yet.